So, welcome to the last talk of today. Short information after this talk. Please remain here. We will set up the stream downstairs. We'll have a small outro keynote again, as on the first day we had the welcome keynote. And afterwards, we'll gather a bit on the lobby for hanging around, and we'll start there an auction and some giveaways. So, it'd be nice if you can join us after the keynote downstairs. So, for now, enjoy the talk.
Thank you. So a little background, my name is Melnykowycz. I work combination scientist, UX interaction design person. So I work on physical sensor development as a research job. I also have a company where we do UX interaction design. So here, if you have any questions at any point, just feel free to say hello. Stop me, and because it's really good when we talk about UX and wearables to also have like kind of an open discussion, because it's something which is very much in play right now. Wearable technology in general is evolving every day with new devices and new experiences. But in general, I like to think about design as something, connecting science to society. And I'm going to talk a little bit about like the evolution of computing, how this affects user experience, sensors, smartphones, and how the experience is being translated to the wearable domain. So as a scientist, we do things, we say we discover things in the world, when in actuality all we're doing is finding ways to communicate what those things are, like quantum mechanics, for example. It doesn't give a lot of value to most people in the world if you explain to them what quantum mechanics is, but if you give them a smartphone that has p-n junctions which function because we understand quantum mechanics, then they love it because it gives value to their lives. But what we look at is this intersection not of science and technology, but using technology to design things that give value to people's lives. So when I think about wearable technology, that's always the first thing that I'm thinking about. What's the actual value to the user, not what's the coolest, latest gadget. Now, as many times in history, when we think about design, we don't just think about technology. We think about society and trends. What are the trends that are going on in society and technology, which are enabling new use cases to come about? So in the future, there's this vision of ubiquitous computing, where everything is connected, everything is a computer, your fingernails are computers, and they're connected to your smartphone, so you can change the color of your lips when you're going to a party, for example. This explosion of Internet of Things and Web of Things is one of the things that's driving the ability to even have wearable computing. And so that's one of the first places that I look at when I think about UX and wearables. When we think about connecting sensors to people, we think about the quantitative self, where people are measuring everything about themselves. And then eventually we're going to have the quantified user, where they won't have to measure anything because it's already being done. It's integrated into their products. But Cisco is projecting that by 2020 we'll have like 50 billion connected devices. So what does this mean for society? What does this mean for UX when we think about product development? For the past, when I think about UX, it's something that I started learning about like 3-4 years ago. I wanted to combine mechanical engineering with UX because it's a way to, I think, interface with people in an interesting way. Now, when I was born and I eventually learned about a computer, it was a giant brick. It was on the table. There was a giant screen. There were floppy disks, and there were CDs. And then we said, OK, we know what a computer is, a desktop, but now we're going to invent a laptop. And eventually, and now, if you use the term laptop, everybody will think of essentially a keyboard that has a little trackpad and it has a screen. Does everyone know what a laptop is? You do, yes. But now that we have the ability to make sensors cheaper and more of them, and screens are cheaper and everything is cheaper and we can have an explosion of technology, we're going towards this ubiquitous computing future, and I'm wondering, okay, originally I was designing an application for a computer. Now it's not just one computer. Now it's like a whole family. It's like an ecosystem. So what does it actually mean for having the user experience of using a program like MS Word. It doesn't necessarily mean I'll just open one thing on one computer. But this has been a way for us to teach users, to teach ourselves, how to use specific products. The giant computer, it always had a mouse with it. And so I would go around and then I would click. And I said, okay, no, we have a trackpad, so now we have a laptop. I'm basically doing the same thing. It's a little bit easier. And then I had a smartphone, and then I started to be able to pinch and zoom, and then I could move things around with 2 fingers, and then I could increase the number of interactions I could have to a computer program with the available technology. But this also means that when I think of laptop, I think of a very specific way to use that particular piece of technology. So for example, a little while ago, the senior VP of engineering at Apple was interviewed, and they were asking him, what's happening with OS X and iOS? And he said, OS X and iOS will never come together, even though, that's what you're doing in some worlds like the Windows world. And he said, why not? Well, because we've optimized the UX for the laptop, that's OS X. iOS is a tablet, and it's also an iPhone, for example. These are 2 completely different user experiences, and they should never come together, which was strange to me because when I first got an iPad, after 2 weeks, I started typing on my Windows machine, thinking I could move the icons around like I could on my iPad. So as we go towards this connected, ubiquitous computing future, I have to ask myself, what's the value in keeping the user experience from 30 years ago when we're still building these devices today? And where do we have technology turning points where we start to introduce new UX patterns and start moving away from the old patterns to bring about new experiences for people? And that's where I come to the idea of user experience from a device perspective versus an ecosystem, right? The great thing about the iPhone is that it was one device in a very kind of narrow user experience. And then everyone says, oh, but look at iOS versus Android. And I think, no, that doesn't make any sense because, of course, as we know, Android is a very distributed user experience over many devices. You don't have one Android device. You have, I don't know, there's probably like 3,000, 4,000 that are out there at the moment, between different screens, different types, different versions that are out there. And on the other hand, the great thing about Apple is always that it was one thing to develop for. One iPhone, one iPad, and you could more or less scale between the 2. But in the ubiquitous world, where we're going towards wearable computing, it's not necessarily going to make sense to just design for one little smartwatch, one little device. It's about the ecosystem. It's about how your experience is going to fit in with the collection of devices that the user has. And that's where I start to make this thought about quantified self versus quantified user. If I wear an activity monitor, if I look at my heart rate, I track my EKG throughout the day, I'm collecting data about myself. I am a quantified self person. And that means I can get data trends about myself, I can create large data sets, and then I have to be my own data scientist. And I have to say, okay, because I slept in longer today, I felt better, and I recorded that in my little application. Most people actually don't want to do that. I mean, many people have started to buy Fitbits so they can track their activity. And after half a year, they get tired because they don't really care how many steps they walked that day. It really doesn't mean anything to them because maybe they don't really feel any different than they did the day before. But that's where the interesting thing of the quantified user comes into play, because when we are collecting data about users and they don't necessarily know about it, or they don't have to interact with the data, then we remove that burden that they have to be their own data scientist. And for me, this is the interesting direction that wearable computing can go in, where the application is being used to affect the person's life without them having to really interact with it. So when I look about the future of designing applications, I think about the quantified user. I mean, it's a person, but it's also an ecosystem of data, right? And so if we're designing user experience, we could be designing specifically for the user, or we could be designing something for the context of that user within their data cloud. And this could mean that we have to somehow bring everything together from a sensor point of view. So when we look at wearable computing devices, it's not just something that I'm tracking one activity. Well, you know, my hand is going up and down, the accelerator on my Fitbit sees it, and then I'm supposed to only use that data set to create an application. I might take the fact that my smartphone is telling a server what time it is, and it knows my heart rate, and it knows that I'm at work, and it's 9 o'clock in the morning. And it also sees that I have a very stressful meeting coming up. It sees that my heart rate is increased, so I'm agitated. And so my smartphone sends me a picture of a beautiful kitten to bring down my heart rate and make myself feel better. You know, that's one possible future. The idea is that we're not just taking one data set and using it, not taking just one sensor and using it, but we're using the full breadth of what we have from a ubiquitous world to design interesting things for people to, you know, improve their lives. So when I think about wearable computing, it's from like a product viewpoint. I basically think about these 4 areas. You know, there's the application you're actually designing. There are the sensors, which are actually gathering the data. There is the data itself, which has to be interpreted, has to be ingested somehow before you can actually use it. But there's the user experience, which should be paramount. It should be the first thing, as with any product design, in my opinion. And when I look at the landscape of wearable products we have now, I think to myself, does it actually make sense that this is a wearable device? Does it really make sense that I'm tracking my movement with my Fitbit when I can already do it on my phone? Where is the added value? If there is no added value, then why are we doing it? Because a lot of the trends right now, what you see with wearable devices, it's all, you know, personal tracking, or it's a second, third screen scenario. Which can be very useful for some people, but we're also running the risk where we say smartwatch and a person thinks Fitbit, or they think, okay, it's a device that has to work with my phone, but I don't really know what it does. I mean, I know it's cool, but I don't really know why I should buy it, but I'm going to buy it anyways, and then forget about it after half a year. Which is a bit of the situation we're in with some products. I would say like sort of the old half-year concept of the smartphone is a secondary device to your iPhone or to your Android phone. It gives you notifications. It tells you you have an email, so it will theoretically save me half a second. Instead of pulling out my phone, I can just look at my watch. Okay, great, thank you, 150 francs. Or yeah, or it's, you know, tracking my movement, and oh, okay, so when I was running a marathon, I saved 150 grams because I used my Fitbit to track my, you know, movements, or I used my Garmin GPS instead of using my heavier phone. But then the organizers tell you have to have a smartphone anyways because you have to call them in case, you know, you fell off the side of a mountain. So okay, well, fine. Where's the added value then for me? And that's kind of what you see also with products like the Nike Fuel. You know, it came out. It was one of the first wearable devices. You know, some people bought it, some people didn't. It came with a smartphone app, which gave you some indication of your activity, and no one really knew what the number meant. And yeah, basically they've stopped making them, and because there's not really a whole lot of value for it. But there's also other interesting products like the Angel. It was on Indiegogo about 1 year ago. They got funded. It's a wearable health tracking device, which is one of the biggest growth areas in wearable technology right now. How can we track the health of people so they're healthier or know more about their diseases? Now, in general, I look at this and I look at, you know, this is the basic landscape of wearable technologies. Some of them have some use cases, some of them don't. But let me go back and think about just what does it actually mean? What does a wearable device really do? Okay. In the very easiest sense, you have a smartphone or you have a wearable device. It has sensors inside of it. What does the sensor do? It does nothing more than measure some physical phenomenon. For example, motion, acceleration, light, UV light, pressure, barometers. It outputs that into a digital signal, which then your smartphone can, or your watch or whatever, can send to a cloud. It can do computations on, and there you have an application in the most simple sense. Now, a lot of our sensors that we have now, they all come from the IC industry, essentially. They're nothing more than wafers that have been etched with acid, and from them, you can create little physical devices that are very, very small. For example, an accelerometer might be something like this. So when this entire mass goes up, there's a difference between these two electrodes, calculating acceleration. Very easy way. If you have a pressure sensor and you go up to the top of the Matterhorn, the pressure is different. And so this little diaphragm will change its position a little bit. And then your sensor knows that you went up 2,000 meters in the air. I think it's useful from a UX point of view to at least understand what the sensors are. Just, if you're a front-end designer, it makes sense you can code something. You don't have to do a full front-end redevelopment, but it's good to know what CSS and HTML are and what div tabs are. So in the basic sense, this is the anatomy of our current smartphone, right? You have GPS, accelerometers, gyroscopes, which means I can go through a city, my smartphone knows where I am. If I go indoors or outdoors, the light changes, so my smartphone screen will change brightness. And I can connect. I have Wi-Fi, I have 3G, I have NFC, and I have cameras. And a lot of times, for example, with motion, the inputs from the GPS, the accelerometer, it'll be put together in a motion processor, or co-processor, as they like to call it. And then this is giving me some motion profile, and this data is actually being used by the application. So, basic smartphone sensor anatomy. Now what I see is interesting for the future is that we'll have all these devices. They'll be smaller. They'll probably be on a smartwatch, as we see with the new Samsung. But we're also going to have other interesting sensors coming out. For example, thermal imaging. Generally when we think about devices and designing applications, we always think about, the two things are essentially combined. You make a smartphone app, and the app is on the smartphone, so you're interacting with the smartphone. But what happens when we start using new imaging technologies like thermal? So Mateo is an augmented reality development company. They make a very nice SDK in Germany. They're based around Munich. And what they're proposing is that as we start reducing the cost of thermal imaging sensors, so actually right now if you want to buy a thermal imager for your iPhone, you can. It's like $125, and then you can look at the people around you and pretend like they're little colorful blobs instead of real people. And what's happening here is that it's essentially taking an image map of everything that's looking at, and when you press on something, when you press on a table or a newspaper magazine, for example, it leaves a little thermal imprint. So this means that they're now able, either through a smartphone or Google Glass or Samsung Glass or whatever glass you prefer, to create a user interface that can be interacted with that's completely devoid from the device. It's part of your environment. On the other hand, I think about what other new parameters would we be able to measure in the future with new imaging technologies. One thing I really like about thermal is that not only would you be able to see things like, there's heat leakage around your house, but we can start thinking more about connecting psychological events in the body. So for example, this study was done with people in a study where they were essentially given words. They were told words which would then enact a different emotion. And then the people used an online app, and they pointed out where in their body this emotion had a reaction. Eventually, I think we'll also be able to use thermal imaging to recreate things like this in real time, so that if you're flustered, more blood goes to your face, you can see that automatically on your smart glasses or your device. So when you're sitting across from someone in a meeting, you can know that they don't trust you very much, possibly. You know that they feel scared, or maybe they feel overly confident. And this could help you increase your emotional intelligence as a person, because all of a sudden you have this new metric for how you think other people are thinking about you, which could be good or bad. But the point is that with the rise of IoT, these things are going to become a reality. Maybe, I don't know, maybe 5 years, maybe less. But with all this rise of technology and everything, you have to ask, what's the actual value to the user? I mean, whenever I've learned about UX, it's always been, okay, you build an application that solves like one thing really well, or maybe 2 or 3 things. But if you start throwing out features, then eventually it becomes a giant monstrosity that nobody wants to use. And that's why you have to think about not actually getting lost in this giant ecosystem. I mean, it's still about identifying the user problem, solving the user problem with the technology available, and doing it in the most simple and elegant way. So this is a nice survey of wearable technologies that I really liked from the last conference in Munich. Wearable Technologies is an organization that puts on conferences in San Francisco, Asia, and Europe, which is all about, as you can see, wearable tech. So we've been sort of talking about this idea of data and devices and users. Generally, I interact directly with the device and the data that is generated about it. But let's think about something simple. Something simple like not getting sunburned when you go in the mountains. Do I need a smart sensor connected to my device, connected to a cloud to do that? No, I can just have a little sensor that tells me I've been in the sun too long, and it's nice and cute, and I go to the beach and I leave the beach when I know I'm about to get sunburned. We can have more complicated things like this little device up here that goes on your wrist, and it has a little thing to measure your blood oxygen, and it's also measuring your pulse. And I mean, it looks kind of complicated, but the other thing I want to talk about in this talk is that these things are also relatively easy to just build and prototype on your own. I think probably for under $500, you could probably build that with an Arduino and an eHealth kit, as I'll show you later. And we also have, there's sort of like crazier technologies that come out, like these M-body pants. Essentially, you put on these shorts, and then you go running or you do your sport. It's connected to a smartphone app, and it tells you what your muscle output was. And you think, wow, that's really cool. I mean, they cost 900 euros, so probably I'm not going to buy them. But for professional athletes, this is a use case, right? Optimization, performance of professional sports is a very big thing. Talk to Nike, talk to Adidas. They love this stuff because it makes a really big difference. But even though they look crazy complicated, at the end of the day, it's just 2 electrodes over your muscles. It's measuring the change in potential as your muscle contracts. That's not crazy technology. That's pretty basic. I mean, that's also something that actually we could probably prototype over a weekend if we were so inclined. But with the thing about the M-body, this is a good concept where the user of the device, the person who's wearing the shorts, they're not actually interacting with the data. Their trainer is interacting with the data, and then they're telling them, you have to eat differently, we have to do a different sleep schedule. This is a good example where you're using a device that the person doesn't have to be their own data scientist. Even better is Modicon. Modicon is actually a Swiss startup. They did their work in conjunction with the AO Foundation, which basically does research for surgical purposes. This is nothing more than a very thin insole that you put in your shoe and you wear it throughout the day. But what it does is it measures the force, it measures the impact force as you're walking throughout the day. Now, that could be really good for runners. It could be really good for people who want to know more about how they're walking. But it's also really, really important for medical research. The scenario is this. You get a hip implant, you get surgery on your knee, and then it's really important for research purposes to know how you're walking on that leg after surgery. So what they were doing in this use case is that the person is walking around after they've had surgery. The data is then automatically uploaded to the server, is used for medical research purposes, and it's extremely valuable because never before has the medical community been able to gather this sort of data in the patient's normal environment. And the user actually has nothing to do with this. I mean, they of course, they know about it, but they don't have to really interact with it at all. creating a nice data profile which is used for something which is really, really important, improving the design of medical devices and implants, and it's complete separation between the UX and the actual user. And it's probably one of the best examples of how I think UX for wearables should be, which is essentially invisible. I mean, yeah, it's great that you have a smartwatch, but you can also go down the street to this tattoo shop I heard in Zurich and get an NFC implant put in your arm. So when you're walking by your computer, you can automatically unlock it. And you don't actually have to do anything. It just has to be programmed correctly, and you have to want to go to a tattoo parlor for open surgery. But there's also people who put magnets into their arms and then put their iPod Nano on their wrist, so they don't have to have a wrist strap, and they can just implant and body hack themselves. And I think that's totally cool. But it's always about this intersection between UX, sensors, and application experience. So a few days ago, Samsung announced their Gear S. This is kind of weird because everyone kind of puts down Samsung because they say, oh, you release all these smartwatches and no one really wants them and you don't really know what you're doing with smartwatches. But they're still one of the most innovative, I would say, forward-thinking companies because they're putting products out there, they're seeing what works, and they're gathering a lot of data also for other people, so we know how to develop better systems. And the great thing about the Gear S is that this is the first smartwatch which is really combining all of the sensors that I have in my smartphone into a small, actually very nice device. So I can do activity tracking. I can look at my heart rate, although, to be fair, I don't think the heart rate tracking on this device is that accurate, as we've seen from past devices. But it also has complete 3G connection. So this is a type of device which can replace actually a great deal of a lot of the wearable devices which have come out in the past couple of years, because you can just design the user experience as you want for this one device instead of having a separate Fitbit, a separate GPS tracking device, a separate UV sensor. I think there's a lot of potential for this because it brings a lot of different experiences together in one package. So this is essentially what I look at when I think about the data and the wearable. I mean, you have to have, you're focusing on sensor development, or you're focusing on how data has been digested and giving recommendations to the user, or you're focusing on the interpretation of this data. But it's very difficult to put this all together into one product. But when I think about developing UX cases for wearables, I still think about, I don't know, basic design process. For me, this is basic design process, modified design thinking, whatever you want to call it. In the first stage, you look, empathy, define. What is the problem that you want to solve for the user? How can we test it? How can we go through some ideation to find a solution for it? And then how can we have a final product at the end? So wearable computing is sort of complicated in a lot of ways because it's a combination of hardware and software. It's not necessarily just a case of paper prototyping, UX workshop, front-end development for a rapid prototype, retest, and then have a final product. But there are still a lot of things that we can easily test and do. So let's take an example, like we want to develop an e-health system. We know we have some basic sensor technologies we can work with, and we're going to choose a use case. So a lot of the cool use cases that we're thinking about now, patient empowerment, how can we make devices that means that a person doesn't have to go to the hospital every time they feel sick? Can they self-diagnose in some ways? Can we do remote monitoring like we had with the Modicon, or rehabilitation? So when I look at, for example, if I'm developing a wearable tech device for UX for a patient, I do the same thing as before. I say, I have a patient, they're empowered, so they know more about their disease, for example, or they can learn more about their disease when self-diagnosing. So, I mean, there's still basic actions they have to do. They have to learn or understand about their condition. If they're gathering data about themselves, that has to be acted upon somehow, and that data has to be quantified. So before even thinking about a sensor technology or anything like that, I break down the use case as I would with any other product. And for example, since we're talking about the wearables in particular, when we're gathering data, a lot of times we think about gathering like qualified or quantified data, right? Qualitative data would be that I'm going throughout the day and I feel better in the morning, so I tell my smartphone app that I felt better today. And then later on, it tracks my sleep patterns, and then we draw a correlation between me feeling good and sleeping more, which is probably the case. But that could also mean different things to different people. If you say you felt good this morning, maybe it's not the same level of good as I feel, or it's hard to compare between two people. But if I take a blood pressure reading and it's 120/80, and you take a reading and it's 115/70, those are two data sets which we can really compare to one another. So that comes to the question of actually prototyping. So prototyping for wearables, if we're really trying to gather data and do something with it, we need a platform. There is so much open hardware at the moment, and there's more coming all the time. So it's actually relatively easy to find a platform that is either a smartwatch or can be modified to be a wearable device, which can allow you to test your idea, to interface with a user, to get data, and then to do analysis on it. So for wearable tech stuff or for e-health stuff in general, for example, the Arduino and the Cooking Hacks platform is really good. The Arduino is an open source platform. Cooking Hacks is a company in Spain which develops this e-health platform. And essentially it allows me to spend, I think, 300, 400 euros. I get the e-health platform, I connect it to my Arduino, which is just a device which, takes a sensor signal, analog, turns it into a digital signal, which I can then do stuff with. And this one is great because I can do EKG, blood glucose, blood pressure, position monitoring, air flow, galvanic response. I can actually create a lot of the products that I just showed from the Wearable Tech conference using this prototyping platform. And after gathering the data, it's also very flexible. I can set it up so it's directly wired to my computer and I can get the data. I could set up a little server with a Wi-Fi chip to send it to a cloud. I could display it in real time, and they even give you a little smartphone app so you can look in real time about the data that you're collecting. So what I wanted to do here is give sort of a larger overview of the trends of wearable computing, what's happening. But at the end of the day, it's all still about the user. I mean, it's about user value. It's about solving a problem. But as we have this trend of IoT, I mean, looking at the device ecosystem, I think is going to be more and more important in how it fits in with other devices. I think it's important for designers to be aware of sensor function, but not necessarily have your own wet lab in your basement and etching your own devices, although it's possible to do if you're into that. And the UI, I mean, it's going to be, in many cases, separate from the actual device that you're designing for in many different ways. But the best solution, it might not be the solution that the user actually sees. So, yeah, hopefully this talk gave you some ideas about where wearable technology is going, how you might want to use it in future development, and how to do some prototyping with it. Thank you very much.
I have maybe a bit of a kind of crazy question. In sense of wearable devices, I would first think of a jacket and shoes like in Back to Future.
Mm-hmm.
That would be much cooler, I think, because today we have all this email spam and it really, this high information and data impact on all the persons, and you get annoyed of that. And I think if you get more devices which telling you something, oh, you got an email and blah, 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 it can be...
Well, I think also in that way, we're still very focused on using text as a way to communicate.
Yeah.
But what we have with wearable technologies is also the ability to embed sensor actuators. So piezo, your smartphone is buzzing, for example. That's generally a piezo actuator. And if we can embed that also into different parts of the body, well, into clothing, which is activating different parts of the body. And this has also been done in some prototypes to build a shirt which is directing a user, for example, if they're blind, through a city using haptic feedback.
That's cool.
So my smartphone will tell me I have to go over there. Google Maps is mapped out, and then it's buzzing here to tell me to go forward, buzzes here to tell me to turn. Yeah. I mean, for me personally, I think the smartwatch is cool. It's the easiest way to implement it, but it's such a small part of like the real potential that we have. And also, you have things like the Ralph Lauren. They just released their activity shirt, which has a little activity monitor in it, very small. But it's also something which is more part of the actual clothing. It's really closer to the user in that way. And for me, what's really interesting is that with the rise of 3D printing technologies, we're also coming into this space where we can prototype physical sensors much easier than ever before. Okay, I didn't want to get into this too much, but since you asked. For example, when we think about rapid prototyping, it's the ability to create these physical objects much more easier than ever before. But it's always like, PLA plastic or ABS plastic, and it's nothing that's functional. You can't integrate circuits into it. But when we mix in things like carbon nanotubes or graphene or carbon black into the feedstock, we do start to open up the possibility of integrating sensors directly into the physical product. And when we start to be able to use more stretchable materials in 3D printers, we start to introduce, and even now, you can download some dresses that are designed for FDM 3D printers, and you can print a dress, you can print prosthetics. So this is only going to increase, and I think it's a really interesting space to be in, to think about the use cases that we could have, look at the rise of technology, and then find this happy medium for where you can realize your vision.
Thanks.
Wunderbar. Well, I'm around. I'm in Zurich and sometimes traveling around other places. So if you have any questions or whatnot, yeah, just search on the Google or whatever. But thank you very much for coming out, and it's been a pleasure presenting to you.
Thank you, Mark.